So this is from Chapter 8, and it's a significance test for sample means when we don't know the population standard deviation, because these things come from a sample. So we're going to be using the t-distribution, but first off, we do need to think about what's going on here. So they're saying last year the average SAT score in math was 515. They went out and did a new sample this year. They found out that the average of those students was 508. So what we're going to try to decide is that far enough away from the old average of 515 to say, it looks like these students that don't prepare for the SAT are going to get on average a lower score. Alright, so we've got to set up HO and H1. So what I did is I went out and grabbed this applet, and it sets it up for me. It said there, and I had to specify that. And now here's what's different about this is I'm testing claiming there's no difference in the mean scores. So because they're not saying that these guys did less than that, I mean, they could have. It wouldn't have been wrong to, but they're just trying to say that there's no difference. So that makes it a two-tailed test, and that's why I selected not equal to. And notice I used the 515, the old average is the center of that distribution. Okay, and I entered, so using this applet, I entered in the sample size, the sample mean, and the sample standard deviation. And just to give you a chance to see how this works, once you get this applet set up, all you got to do is press calculate, and it'll tell you the test statistic. It'll actually give you a nice graph to show you the area, and you see that it is a two-tailed test. There's the degrees of freedom. Of course, we knew that because that's just n minus 1. And there's the p-value. Now, if we wanted to do this with just straight p-values, well, I think they told us that this is the 5% level of significance. So that we're going to compare that to the p-value here, and since this p-value is the area that we're wrong, if we decide that HO is wrong, well, that's not as small as the level of significance, so we cannot reject HO. We can't say that the people who don't study had a lower average than the people who did, or at least the overall average last year. Okay, now if you want to do this with critical values, well, then what we need to do is we need to go to that T table, and I went out and grabbed a copy of that, and I'm looking at 49 degrees of freedom. And I'm looking at the 5% level of significance. So this is a two-tailed test, 5%. So we're going to compare. There's our critical value of t is the 2.01. And if we look at what our test statistic was, our test statistic was 1.45. Well, it was negative, and we could, since this is the absolute value of what we're looking for, we could consider negative. Let's make a sketch here. We could consider negative. Let's see which one we got. 2.01 or positive 2.01, and anything out beyond that is the rejection region. And of course, because this test statistic doesn't fall out that far, we can't reject HO. Same decision. You would hope it's the same decision. Okay, so that's how you do these kind of questions. If you wanted to calculate the t-score, well, that's just like calculating a z-score. If you need some help with that, give me a yell.